Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to keep talking about my current project, which is coding a combat system for a viewer's game. Specifically, I would like to finish up talking about initiative. In my previous video, I showed you a system for individual initiative. By individual initiative, I mean that each character, whether they be on the player character's side or an enemy, rolls individually for when they get to act, as opposed to group initiative, which is something I've already dealt with, where you roll to see whether sort of your side goes first or the other side goes first. This is more detailed, so we might have sort of some enemies going first, and then some player characters, and then other enemies. I showed you a system that was almost complete. There was one problem, and that was what happens in the case of a tie. And the viewer whose game this is, or whose game this is for, has told me that the player character wins ties. They haven't told me what happens with companions, but I've assumed that the intention is the same, that the companions get to go before an enemy if they roll the same initiative as that enemy. In my last video, I said that I thought the system already took care of making the player character go first. I realised that was a mistake. That isn't true. Sorry, go first in case of ties. I've since seen that is not true. But anyway, I still had to deal with making sure that companions win ties. So I've done that. And I'll show you how it works. So we have an example of a combat here. We have a player character who's rolled a 7. We have a companion who's rolled a 5, and we have another companion who's rolled a 9. And there is a monster that's got a 7. There are several enemies that have 5s and 9s. So if this system that I've coded works, then when we press continue, the player character should be before the monster that got a 7, and similarly the companion 1 should be before the others that got a 5, and companion 2 should be before the ones that got a 9. So let's have a look. Yep, well, there's the 5s. Companion 1 gets to go first. There's the 7s. The player character gets to go first. And there is the 9s, with companion 2 going first. Out of the ones that got a 9 is what I meant there. And similarly for the other two. So it looks like the system is working. Let me now show you the code that allows that to happen. So we have only one new page, and we don't have any new variables. So we only need to look at this single page. Maybe we'll look at this one to show you where this one comes in the order of the program. So let's go back to that. We'll go to the roll initiative. Sorry, I think I was clicking the wrong ones there. Sorry, this is the new page. Sorry, I was sort of one over. This is the new page, and this is the place where that page is called in the program. So this is the page that I had last video, so I won't go through it in order, but basically this is swapping any ones that need to be swapped, and sort of down to here. From here on, we have printing the results, and all I've done is just put include break ties. So in between basically sorting them out and printing out the results, we now have a new page. What we'd probably do if I'd sort of had this bit from the beginning, I would probably goodness me. Sorry, I'm having a bit of trouble getting this thing to... There we go. If I'd done this from the beginning, I'd probably have sort initiative here, and then it would go to break ties, and then it would go to display, and just have them as separate pages. That would be a bit more intuitive, but I just did it in a slightly awkward way because I already had it set up this way. I might fix it. I might fix it later, or I might not. Anyway, let's have a look at what break ties does. So we have a little note to myself that says, characters on the PC side go before enemies in case of a tie. So broadly what we do is we set a temporary variable Z to 0. We go through all the slots to see if there's any cases where we need to swap to enable this to be the case. And if there are, we set Z to 1. And then at the end of that, if Z is equal to 1, we include break ties. Well, this is break ties, so essentially we go to the top of the page and do it again. The reason we might need to do it more than once, because we might have, as you saw in that example, we might have 3 or 4 enemies that have a particular initiative and one character that's on the player's side, and they might be, say, second, or they might be, say, fourth. Well, if we swap them once, that's not enough. We need to sort of swap them until they get to the top of that part of the list. That's why we have that flag to see if we need to check it again. So it'll keep doing it until it runs through the list and finds nothing that needs to change. So here is how this bit of code works. We have a for loop. Starts at 1. Its condition for continuing is if y is less than y2, not less than or equal to, which is the normal condition that we have for these for loops, and then y++, which is just the normal the normal thing we do at the end. All right, so this is the bit of code that checks whether we have 2 slots that need to swap. Now remember, everything is in numerical order when we get to this. We've already sorted things into numerical order. We're just sorting out any problems within people that have ties. So we don't need to, or characters that have ties. So we don't need to compare every slot to every slot. We just compare a slot to the next one over. This is why we have less than y2. We have if I and I y2 is equal to I and I y plus 1, 2. That's why we have less than rather than less than or equal to, because if we had less than or equal to, we'd be looking at I and I y2 plus 1 at some point, and y2 is the total number of characters. And so that would be looking at a slot that isn't really meant to be looked at. So if I and I y2 is equal to I and I y plus 1, 2, and I and I y1 is less than 0, and I and I y plus 1, 1 is greater than or equal to 0. So what does that mean? Well, I and I something 2 is the actual score. So if the scores are equal and the lower one, the one that's one lower in the order, I and I something 1 is what character this is, and a negative number indicates an enemy. So this is saying if the one in slot Y is an enemy, and similarly 0 is the player character and over 0 is a companion of the player character. So if the one that's lower in the order is an enemy and the one that's higher in the order, which means the one that will go last or second out of those two, if that one is a player character, well, that's a condition where we need to swap, because player characters and characters on the player character's side are meant to win ties. So what we do, this is very similar to the code that we looked at last video, where we're swapping the values of INI Y1 is going to with INI Y plus 1, 1, and we're swapping INI Y2 with INI Y plus 1, 2. So I've talked about how this works, but essentially it swaps the values of those two pairs of slots in the array. So the character that's on the player character side will take the lower position, which is the better condition, the better position, because slot 1 is who gets to act first, and then slot 2 is who gets to act second, and so on. The only thing that's different with this code is we also set Z equal to 1 to let the computer know, that yep, we found one, so we're going to need to check it one more time at the end of this run through. And then we end the for loop, and then if Z is equal to 1, if we found anything that needs swapping, well, we include break ties. We look at it again. And eventually, everyone will be in their correct position, and so we will go all the way through, not find anything. Z will be equal to 0, and we'll on this page, it'll come out of this include and print the results. And that is how that works. Now, I said I wanted to finish up with initiative, but I might do one more video on what if you don't want the player characters to win all ties. What if you want it to be random? So if we have 3, let's say 2 monsters and one and the player character, if they all get the same initiative, then we randomize who gets to go first, second, and third. So I might deal with that in my next video, but after that we will be done with initiative, and we can move on to other elements of the combat system. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.